Hello, ladies and gentlemen. Today we're going to cover 3.5, which is another rule of differentiation. This time we're covering exponential functions and logarithmic functions. Okay, and so let's get started with the differentiation rule for exponential functions. And so what it says is whenever we have a exponential function with the base of a, and where a is greater than 0 and a is not equal to 1, because that would just be like the function 1, then f prime of x is equal to the natural log of a times a to the power of x, okay? And so what this is basically saying is like our base is going to be, in this case, a. And so we're taking the natural log of the base a times what our original exponential function was, okay? And then we apply any chain rules to that, okay? So you'll notice that in previous examples here, we had, e to the cosine of 2x, and we took the derivative of e with respect to the inner. So we took the derivative of e, which is e, and with respect to the inner, which is cosine of 2x, and then we took the derivative of the inner, that cosine 2x. The inner of that was the cosine, and we took the derivative of that. That gave us negative sine with respect to the inner, which was 2x. Times the derivative of the inner again, the second inner, that being that 2x, which is 2, okay? And then we could simplify, and we ended up with this answer. So this same concept, you'll notice that I can apply it to this rule up here, where we let our base be e, so we take the natural log of e, times e to the cosine 2x, times the derivative of the inner. That would be the derivative of cosine 2x is negative sine 2x times the derivative of that inner 2x, which is 2, okay? And then we simplify. We know the natural log of e is 1, and it comes out to being the exact same thing, okay? So here we have a couple examples applying this new rule of finding derivatives of exponential functions, okay? So we'll do a couple examples near the end. I'm going to do 5 examples from this lesson that highlights obviously some of these problems, okay? And so you'll notice that we're applying different rules like product rule right here. Here's a product rule and a chain rule. Here we have a quotient rule again with a little bit of chain going on. And then being able to find a normal line. Remember, the normal line occurs when the slope is opposite reciprocal. Okay. Here's the other differentiational rule, which is logarithmic functions. And this one's very similar to when we were doing natural logs. The only difference here is that this is log with a certain base that's not a base e. So it says that if the log of base a of x, where a is greater than 0 and a is not equal to 1, then f prime of x is equal to 1 over the natural log of our base a times x, x being this inner part here. And then if we have to apply a chain rule, we'll apply a chain rule to that. So example in the past, we knew that natural log was 1 over x with respect to the inner, that inner being that sine of 3x, times the derivative of the inner, which was 3. Okay. And this does not seem correct. There should be a cosine here. So we will fix that in a moment, and we'll fix this guy here too. But as I look at this guy, this is sine of 3x. Yeah, we'll fix that later. Okay, so don't ignore this part. I will fix that in the notes here. But let's look at our example here where we have log base 2 of 4x. So we take the natural log of our base, 1 over natural log of 2, times 4x, that's this inner part here, times the derivative of the inner, which is 4. And then we can reduce it down to 1 over x natural log of 2. Another example where we have a base of 3, so it's 1 over natural log of 3. Derivative of times with respect to that inner part, which is the sine x, times the derivative of the inner, so the derivative of sine x is cosine x, and there we go. Okay, so let's do a couple examples. And you'll notice that so they can get a little bit more complicated. So let's do our first example here where we have exponential derivatives. And this is right here, this is going to be product rule. So I'm going to move this down here. And we have a product rule. So I'm going to take the first being 2 to the negative theta, and the derivative of cosine pi theta. Well, this is going to be a chain rule. So we have to take the derivative of the inner with respect to, the derivative of the outer with respect to the inner, times the derivative of the inner. So the derivative of pi theta is just pi, plus we're going to then take this, the second, which is cosine of pi theta, times the derivative of our first function. So our first function is an exponential. And so when we write that, we write this as the natural log of 2 times the natural log of 2 times the base of 2 theta, okay? But this is a chain rule because the inner, in this case, is the negative theta, so this is a -1. And then we're just going to simplify this a little bit. So I have f prime of theta is equal to 2 negative theta pi, and we put the negative on the end here, sine of pi theta, plus we have a negative, so we'll get rid of the plus and we'll put a minus, 2 negative theta, natural log of 2, cosine of pi theta. We could factor out the -2 negative theta, but I think that this is an appropriate answer. Okay. So we have our answer here. Let's go here. Just making sure. I don't think we need to simplify any further than that. Yeah, we don't have to simplify any further than that. This is great. Okay. Okay. Let's look at another example here where we have a quotient rule. So I'm going to take the bottom times the derivative of the top. The derivative of the top would be the natural log of 3 times 3 to the power of 5x times the derivative of that inner, which is 5, minus the top, which is 3 to the power of 5x times the derivative of the bottom, which is 1, all over the bottom squared. And then we're just going to simplify this, clean up the top, so that we have x, 5x, we can put the 5 in front, natural log of 3 times 3 to the 5x minus 3 to the 5x all over x squared. And so I'm just going to factor out that 3 to the 5x. So I have 3 to the 5x times 5x natural log of 3 minus 1 all over x squared. Okay. And there's your answer there. Okay, now we're getting into those logs. So remember that we do f prime of x, we write this as 1 over the natural log of our base, which is 2, times 4x, times the derivative of the inner. So the derivative of that inner is just 4. And so we end up with f prime of x is equal to 4x natural log of 2, and then that was all over that 4. And then we could pull out that 4, so we have f prime of x is equal to 1 over x natural log of 2. Okay? Let's see if there's another one we could do here. Okay, so we got this time we have a mixture of the logs and the exponentials. So what we're going to do for this guy is we're going to do p prime of x is equal to, you could do 1 over the natural log of 10, or you could just write it as so write this as natural log of 10 times 2e to the 3x. Take the derivative of, with respect to inner, so this is 3. We have to take the derivative of this guy here. So this will be the natural log of 2 times 2 to the 3x times the derivative of that inner, which is 3. Okay, and then we're going to simplify this. So this gives us 3 times 2 to the 3x natural log of 2 all over the natural log of 10. And I'm going to put the 2 to the 3x in front of that natural log of 10. So I have 2 to the 3x natural log of 10. And then we'll notice that the 2 to the power of 3x on the top and the bottom cross out. And we're left with p prime of x is equal to 3 natural log of 2 over the natural log of 10. Okay. Our last example here is another type of chain rule here, where we have that log. So we have k prime of x, and we're going to take the 1 over the natural log of 7 times the derivative of x squared minus 1. And then we have to take the derivative of this guy here. So the derivative of that guy is 1 over 2 rad x squared minus 1 times the derivative of that inner, which is going to give us 2x. And I'm going to just clean this up a little bit. So when I clean this up, I'm going to get k prime of x this is 2x over 2. So those 2's cancel out, and I'm left with x rad x squared minus 1 over the natural log of 7 times the square root of x squared minus 1. Okay. And from here, I could just continue to write this where he's on a fraction of his own. So I write this as x over the square root of x squared minus 1 times 1 over natural log of 7 times the square root of x squared minus 1. And I could see that I have a square root of x minus 1 and the square root of x minus 1, and that just becomes k prime of x is equal to x over x squared minus 1 natural log of 7. Okay. And that is our answer. Okay, so ladies and gentlemen, that was right there. Finding derivatives of exponential functions and logarithmic functions. Please jot down any questions you have, complete your homework, and let me know what I can do to help you to be successful as we finish up Unit 3 here. So we have 2 more lessons after this, and then we are done. Have a wonderful day, and keep studying, keep working hard. You got this. You totally can do this, and you are on it. Okay? So long, and I'll see you soon. Bye.